the latest from, then do join us for that presentation at 11:45. We'll then condense the afternoon down into one session, so the three remaining sessions of the afternoon will run concurrently, so do join us for those as well. And if that's not clear, you can check the conference app, which has been updated with the latest programme. I'd also like to start this morning by thanking our gala dinner sponsors, Sesto. I hope you all managed to join us last evening for a very memorable night here in the conference room with some wonderful dances celebrating Vietnam and some local music as well. So I'd like to thank Sesto once again for their sponsorship of that event. We heard yesterday a lot about the challenges of overcapacity and decarbonisation. They're two of the major challenges facing the cement industry in this region. But how do you tackle both of those simultaneously? What you need is smart investment, clear goals, and effective project management, efficiency, productivity, and the best available technologies. And that's what we're going to be looking at this morning. Our first presentation is by our good friend Tammoy, from CRHF in Dubai. And Tammoy is going to be talking about these exact topics, looking at effective project management, capital expenditure, cost and time quality. So please put your hands together and welcome Tammoy to the stage. Thank you.
Thank you. Good morning, ladies and gentlemen. My name is Tammoy Ghoshal. I am from CRHF LLC UAE. Yesterday we have discussed lots about how we do the shipment, what is the situation of the market, what is the challenges in the cement industry. So today, if we go for the vertical integration of the same problem, so here actually we will discuss about the project and the capex. It may be the brownfield, it may be the greenfield. So how we can optimize the capex in terms of putting some of the efforts, technical and commercial, and which will ultimately benefit the profitability and return of investment for the investor. We are basically the engineering and consulting company. We do the management consultancy and strategic consultancy. We also arrange the fund for private equity in the cement investment. It can be the acquisition merger or it can be the new project. So we help the investor to make their ROI and IRR of the investment in safe for the whole ecosystem of the life cycle of the project investment. So here we go. The project management is a very vast subject, we know, but I will try to do some analytical things here so that it can be understood that how it can be done for a real life situation. And we'll touch the major points, which is actually the analytical part of the project management. Basically, in maximum cases, the project management is done on the basis of quality and qualitative words. But here we are trying to do the mathematical interpretation of the project management. So let's start. Thank you INTERCEM for giving us the opportunity for beautiful guests. So the purpose of the presentation is basically the analyzing the project to build cement plant from investor perspective, achieve sustainable desired ROI. So when we put the money from the investor for a capex project, for a new project or maybe the expansion, so what are the challenges and how we can manage more to get the project return the best kind of investment return. Sorry. Understanding known and unknown challenges from various fronts and mitigation approach during project execution. Establish the monitoring and control system with techno-commercial approach for project capital investment management. And risk management, this is a strategic part of the project management. So risk management and advanced alert system to forecast downtrend, action plan, understanding all round techno-commercial challenges, and ensure investment goal to be intact throughout the whole investment life cycle. So these are the major intention for this presentation. So there is the stages of the project. If we define, first is the project development. Is basically the owner's keenness for the starting of the project, like the initial pre-feasibility kind of thing. Then the project initiation, then the project planning. Then we go for in the planning we go for the whole thing like the feasibility study, the bankability of the things, and we take the financial closure. Then go for the design, construction, commissioning, closing, and ultimately the handover to the owner. Okay. So the steps for the current challenges, what we feel for the CAPEX project, it depends on various geological position of the plant. So we feel the first is the market entry, which is like say country like Vietnam, the market entry also is a big challenging thing because lots of competition. And sovereign and macro risk, it affects like dollar situation of the country, foreign exchange reserve, and other macroeconomic point of view of the location. And the project budget, fundraising and managing project cost, delay of project execution and consequential financial impact, techno-commercial real-time viability of the project. So this is very important for the project management. We will discuss in the next slide more on this. Project cost overrun. So how to identify the overrun and what can be the approach to optimize that. Uncontrolled interest during construction. So maximum projects are on debt funding. So if we don't manage the project properly, so there will be uncontrolled IDC, which also having a big impact on the project viability. Then all this will affect, if we don't manage properly, the investment IRR, debt service coverage, and ultimately the payback of the investment. So basically we can define a few scopes. The scope will basically work out to optimize the quality, cost, and time. So we should fix the proper micro level monitoring plan for budget, activities, time, quality, and of course the health and safety. Framing of the time for milestone and monitoring, maintaining quality as per design basis report, and budgeting and monitoring of cost with cost control method. So the monitoring and measuring the project cost, schedule, and work performed against project management plan at any given point in time is important because when we go for the project whole life cycle, so at a particular time where the situation, where we are lagging behind, so that we have to monitor. And investor perspective, most efficient way to manage above is basically unvalue management. Like what is the, say after 3 months of the project, how much is the unvalue of the project? That is the most crucial for this. So how we'll do that, we'll come in the next slide. Then the effective handing over of the project on completion. So it happened that many times project completed, but it is not properly handed over. The drawing is not handed over. So that in future when you go for some changes or you have some problem of the plan, you cannot refer the earlier engineering or earlier drawings. So it makes lots of difficulties for the operation team. And of course the project audit on a fixed interval to ensure the value addition at particular time point for the project division. So now a little bit of mathematics. How will go the unvalue management system, which is the most efficient way we feel. So basically I try to define here. Let's say the one part is the total budget for project, so we call it BAC. We have a graphical presentation of this, so it will be most easier to understand. So we have the earned value, which is basically the total budget into the actual completion. We have the actual cost, and we call PV, which is basically the planned value. So what is approved budget assigned to scheduled activities. So now when we go for the project, so we don't go as per the, it happened that 80% of cases that it does not go with the actual budget wise. So there is a cost variance. So cost variance basically the earned value minus the actual cost. Same we have the schedule. So say maybe the project planned for the 2 years, out of that 4 months passed, and we did not reach to the particular level of progress. So there is called schedule variance, and there is a, we call it CPI to manage the project. So cost performance index, which is basically earned value by actual cost. And same for like cost performance, we have a schedule performance, SPI. So similarly, we have estimate completion monitoring system. We have the estimate complete and the variance at completion. So I will go for the easier way to present this. So to all this we have defined, we call TCPI, to complete performance index. So basically all these parameters is a dynamic. So every month we should monitor these parameters and we put the graphical interface of the whole thing so that we can understand the project situation on a mathematical way, so that there will be no human perception involved in the project monitoring and project management. It will be all mathematically put. In fact, we can run through some, we have developed some software kind of thing. So you can put in the app, and we can see the runtime parameter of the project situation. Okay, now whatever I discussed in the formulas, the same thing I try to explain here. Let's say the project was planned for 24 months for a cement project, and the black line is basically this line is going to the planned project activities, and this is showing the progress. And let's say we have reached this much of situation. And with this situation, with this time, our plan was this, but we reached this schedule, but we have put a cost like this. So this is a $50 million of, let's say total project is 75 million, and out of that, say 50 million was our budget for this progress. And we have reached to this level, but we have made the cost incurred this. So this basically PV, AC and EV. Yeah. So this sheet you can understand more elaborately on this. Let's say on the, sorry. Okay. Now let's say this situation where we plan for total project of 75 million. Say our plan was 50 million in the 12 months to do the activities of 50 million. We achieved the earned value there, which is around this 30 million. But actual cost should be, actual cost incurred is the 35. So this is basically the schedule variance. So this 50 minus 30, so 20 million. And this is the CV. So if you see, in the both direction, project is in a very, very negative territory. So this can be done in every month, in every 15 days we give the report to the owner, to the investor, outside investor or inside promoters. And we analyze that every 15 days the situation of SB and CV. And from that, mathematically we can get the project is in a danger zone or is it in a comfortable zone. And if you see the CPI both are, SPI both are below the CPI is 0.86, SPI 0.6. So both showing the project is in a danger zone. So then comes the mitigation action, that how we can mitigate that, what is the real problem for this, so that micro level analysis has to be done on that to solve this issue of the unvalue, based on the unvalue analysis. So this is very popular, and particularly for cement industry, which is very capital intensive industry. And you know, maximum project goes with the 70% debt funding. So which is it is very important to monitor this, track this, In fact, if you shave IDC of say 10-15% for the whole project life cycle, it gives a huge boost for the IRR for the investor, and which will ultimately help for a payback period of the project. And particularly the market like Vietnam or India or China, where competition is very high, so saving of during the project planning, project execution, saving of even 5% of the total value of interest can give a lots of boost for the project investment. The same for the when we make the project planning and we go for the project execution, we have the various level of contingency. So let's say we make the 15 contingency plan for the whole for 24 months. So step by step we can take up the contingency when the project goes delays or some challenges comes, and we take care of the cost contingency and the schedule contingency accordingly, and we see how it goes and how it impacts. Sometimes it happens that we have experience, even we have put in the contingency, even we can come out with the solution for the earlier the planned value and earned value, which is negative. We can accommodate that during the project execution, and we ultimately achieve the target time frame and target budget. Okay, now whole thing we see the mathematical part of the earned value. So in the background, basically the ultimate reason for whole thing is basically the delay. So the delay management for the project and delay analysis from the grassroots is very crucial for the project. So how we do that in a mathematical way, and how we make the delay control. So there are various ways of delay analysis, but we feel that for cement project, which is basically slow moving because you have to have a curing time for the concrete building. So we have a delay analysis techniques for two kinds of retrospective and prospective. And retrospective we have as planned, as built, and prospective we have time impact and impacted as planned. So this presentation will be available in the soft copy, so you can read more on this if you are interested. So I try to define in a short way how that as planned delay analysis, and how we go for the, let's say we have the time impacted as planned analysis involves the insertion of delay events into a baseline. So basically whatever we plan and whatever we have achieved. So we make the timeline on that, we do it as planned basis. And another approach is the as built. So whatever plan we have done and whatever we have built, so on that we can have a delay analysis approach. And we can see the as planned versus as built in the same graphical bar chart, and we can see that the change of the critical path of the project, which is also, if you, why it is important that every 15 days we do it, if we see that there is a big mismatch of as planned and as built, and the critical path is going to change, then we try to take some mitigation action to take the critical path back in the same zone which is planned, to take the project so that next month will be recovered. So another way is the time impact analysis. So basically each delay event, we put all the delay events individually in chronological order, and we quantify each delay based on the schedule. And same way we do the window analysis. Basically window analysis is much more relevant for the project like us, because there are lots of micro activities like doing the concrete building, then the machinery coming in the ground and putting the machinery, doing the erection. So each window we make that, and we make the analysis of each window this, and we try to put in a figure. So what is the mathematical, like let's say how many days delay, what is the offset from the main bar chart. Okay, so now the commercial part of the delay. So when we have the delay and we manage it from the commercial way, like how the delay will be accountable. So we have to put basically the down the line, we have to have a very good contract with the proper contract with the contractor and the supplier, so that the delay because of them can be properly put in the accountable, and we have to take care of that. So delay, we can have the two kind of thing. One is excusable and inexcusable. So delay can be the owner part, delay can be because of the contractor, or delay can be the both. So I tried to define here that which are the employer risk event, which is ERE, and another is that contractor risk event. So excusable, so which is the employer risk event, which is basically the owner's risk event. Delay because of us, we could not put the money, or we could not make the clearance, or there are some other delay which is macro event, like the COVID like of situation. So we put that which is excusable, which is non-excusable, and which is non-excusable, we have to also have a plan to put the figure on that how much is the value, in terms of the project cost. And accordingly there should be a claim. And we have to also match it with the contractor's liability. So this is also part of a project management. So I tried to more define here, so you can see in a soft copy in a detailed way, like the excusable delay, which is a compensable, and what are the type of delays, like the delay to furnish or deliver, delay from owner's side. So we cannot keep the site properly, we have the communication issues, we have the decision making issues, there is a suspension of work because of the government issues, there is a drawing did not come properly, or we did not get the permission, so these all are the things. So there are concurrent delay also, like the force majeure. So like we have lots of experience during the COVID to imply the force majeure situation. In fact, even if we don't have the force majeure, there is another kind of situation we call it doctrine of frustration. So that can be also implied in various situations. So like the fire, flood, wind damage, suspension, so this cannot be clubbed in the money. So that means this is all on the risk event. We cannot claim from anybody. And there is a non-excusable, which is basically the contractors or the suppliers, which is basically we can convert it to the monetary part. So like the poor site management, rework, there is a staffing problem from the contractor, then the delay in the subcontractor's work, then the inspections delay, material and verification delays. So these all are basically the non-excusable, and which can be converted to the money for and which we can recover the loss from the contractor. Now these are the delay analysis technique, and now these all are basically if the delay happens, how we'll mitigate that. So we have various approach to manage the delay in the project, and which can save even at least 80% of the delay event. So we have the forward approach and backward approach. In maximum project, we say this is the initial planned finish date, and delay happens. So each activity wise we can put the analysis, and we see how we can take it. Like say, based on the critical path. Same way, we can also shift the actual finished work, and we can see how best we can cover up all the delay and take the forward analysis. In the backward also, we take the last finishing date, cut-off date as per the current situation, and from there we go the backward, and how we can safeguard the final date of commissioning to make the thing happen. So these all are actually every month we normally give analyze and make it for the owners or investor. So now the strategic part of the project management. So above all this analysis and doing this is a basic thing which we need to plan before starting the project and during the project. So one is that technical design margin, and because the market is dynamic, so there has to be a marginal potential capacity of the plant when we design. And very important to manage the finance, spread the drawdown. We need the machine now, We don't need the machine, say after 3 months, no need to pay immediately for the machine. We can have opened LC and accordingly spread the drawdown of the fund so that we can save the interest during construction. Then we have the strategic debt equity ratio and managing debt drawdown. So since 70% or 75% we go for debt funding, so strategically we can draw down the debt so that our equity contribution will be also accordingly addressed. So these are the dynamic project management, strategic part of the project management, which will give the recommendation to the owner to make the strategy so that we can efficiently manage the project fund. So by all doing this, we can have a clear margin of debt service coverage, which is very important because in today's world, the high interest rate of Fed and US dollar situation is very tough. So if we manage 3-4% of the project time per year, it's a huge impact on the total project cost and feasibility. Same like, as I told you, the contract, taking the money out from the contractor for the delay. Can I have the water? Madam, what? Okay. Okay. Yeah. For contract management, we have to make the proper contract and agreement with all binding terms and clear performance guarantee management protected by bank guarantees. So we normally go with the FIDI or the ICC terms for the contract with the contractor. Delivery and freight management and long delivery, short delivery management, proper billing schedule, construction management, project item inventory management. This is very important. So how we make the inventory management for the project items, and force majeure intervention, like how we define the contractual terms and the force majeure, which will actually help to manage the project smoothly and avoid any kind of confusion with the later date when we go for the claim. And with the project management, we have to also do the payment and the cash flow management. So payment terms should be planned with cash flow down and cover unsecured payment with security in terms of bank guarantee. So there should not be any unsecured payment for the contractor. And project implementation plan, equipment erection, equipment delivery, payment terms should be all linked and dynamically controlled. So major challenges are the delay management with tangible and figurative measures, cost overrun in terms of internal and external factor with macroeconomic consideration. So these all are basically the challenge which we have to put in the project management strategy. And when we generate the every month strategy report for the owner, we have to take care of all this. And all this will impact for the cash break-even and industrial inflation. And anytime project duration, revaluation of the investment, like say project goes for 6 months, we don't know the situation. If we don't know after 6 months what is the situation and what is the impact on the whole project plan, on the financial model, so that we have to see regularly. Okay, now another part, during the project we have to also see the risk management, like sensitivity analysis. If during the project we see that in 6 months, the market changes, that if the commodity price goes up, if the copper price gone up by 50%, so what will be the impact on our investment model? So same for selling price, same for the other situation of the event, which will impact, how it will impact on our investment plan. So with this also we need to do some of the other things like the mine and geological assurance, like proper limestone assessment, location and logistic viability, and the brand position strategy, and of course the capacity selection. Same we should do for the commercial viability, so viable financial model. So each each month when we do the analysis of the project, we should reassess the whole thing regularly, so that if there is a big change event happen, so we have to accordingly take care of our position to assure that our investment model is intact, our strategy is intact. So thank you very much. We do this regularly for big investment in the cement, mining and power across the world. Our focus is Africa, Middle East and Asia. And if you need any further clarification, I'm here. We can discuss and we can take it forward. Thank you. Thank you.
Thank you very much, Tammoy. Okay, I think if you have any questions for Tammoy, perhaps you can grab him in the coffee break. That's probably the best option there. What we're going to do is we're going to move on. We're going to look at some of the projects that you might want to utilize some of these project management advice for. The first one we're going to look at is alternative fuel flexibility and the benefits of the KHD PYROROTOR. So we were talking yesterday a little bit about alternative fuels as one of the key levers for decarbonisation, and also the cost savings that you can make by not using traditional fuels. So we're joined by Andreas from KHD, and Andreas, take it away.
So also good morning from my side, and a warmly welcome here for my presentation for the unmatched alternative fuel flexibility with the usage of a pyrorotor system. So in this presentation I want to give you a rough overview about the alternative fuel firing challenges, what the cement plant producers have to look for, which influences the alternative fuel usage has for their existing system, what they have to think for. And then, especially, I want to give you the introduction for our PYROROTOR, the new system and product in the KHD family. It's on the market now since approximately 6-7 years, and already a lot of cement plants worldwide are using it. They're happy with this system, and yeah, I think you will see it. So just let's start with the challenges and the rough overview for the alternative fuel usage in the cement plant. So, in generally, when you are using or want to use alternative fuels as firing or fuel system, you have to look for many challenges, positive and negative things, which are influencing your existing system. So in general, what you can say, this is the influence on the energy balance, then also the energy, the influence on the plant operation, stability and the availability. You have also the influence to the influence of the clinker quality, and as well also the influence to the emissions. So in generally talking, when you're putting alternative fuels inside the system, you have to think for that these alternative fuels are consisting of a high amount of moisture, what you're putting inside the system. This means regarding to the influence to the energy balance, you can see that there's a high increase of the waste gas volumes, and you're also shifting the temperature profile in your preheater. This means due to the moisture just going out of the alternative fuels, the waste gas volume will expand. So this means maybe you have to think for also changing some other equipment inside your plant. This could be some changes in the top cyclones if it's not sufficient to get the right separation effects. This could be the influence also to the ID fan, because the amount of waste air is increasing by 10-15% maybe, just depending to the amount of moisture what you're eating there. The shifting of the temperature profile is just coming from the burning behavior of alternative fuels. This means you're feeding lumpy sized materials maybe, and they just take a longer time for the burnout process at the end. And by this shifting or by this longer time for the burnout of these materials, you're just shifting into the lower stages of the cyclones, and at the end the temperature profile is a little bit changed. This means the exit temperature behind the preheater could be increased by 10, 15, 20 degrees Celsius. Also, when you want to burn alternative fuels, you need higher oxygen for the burning itself. This means not only 2-3% oxygen kiln inlet or behind calciner will be sufficient. There we are talking about 1% more maybe. And also by feeding these alternative fuels, you are putting inside a high amount of chlorine, sulfur, all these other things inside. This means at the end already coming chlorine contents from the raw material, which are creating maybe already problems in the calcinerizer duct in the lower cyclone stages in the preheater, can also influence by these alternative fuels with an additional amount of chlorine and so on. So you are having problems then maybe in these areas, and you have to add also a kiln bypass system, which is creating an additional heat loss of some kilocalories. But not only all these negative effects, what I've just talked to you now are influencing the usage of the alternative fuels. Also, there are some positive effects by using alternative fuels. As you are reducing the CO2 footprint because you're not using the standard fossil fuels, what is normally used here in Vietnam, for example, with a coal or with natural gas and so on. So this means the CO2 footprint is definitely reduced by using the alternative fuels, which is already now a high demand on the market. And another positive effect is that by the burning of the alternative fuels with a lean gas with a CO-rich environment in the burning, you have the positive effect that also the NOx emissions are reduced by a positive reaction of the carbon monoxide created just from the burning process. So we are talking here about especially then in the pyrorotor, but therefore I want to give you later some information in the presentation. We are talking here about that the NOx emissions will just coming down by using alternative fuels and to a level of, let's say, 500, 600 milligrams already behind the preheater system. Okay. When we look to these challenges to the system itself, you have to look also for other challenges when using alternative fuels, and this is the alternative fuels itself. So when you're thinking, okay, we can use it, we are happy to use it, we see the challenges, this is okay for us, you have to think for also to get the alternative fuels from the waste storage from the areas outside in the right amount. So we are talking here about values of minimum 10-15 tons per hour, which is going up to, depending to the plant size and the substitution rate you want to use, up to 40 or 50 tons per hour. This means up to values of about 1,000 tons per day alternative fuels, and this has to be handled and has to be available also on the market. And then also depending to the system what you want to use, because there are very different solutions on the market by using alternative fuels. You have to look when you are getting the materials, how is the situation in your plant or from the supplier of the alternative fuels, how you can get it in the right size, with the right moisture, with all these things you have to think for. So at the end, you have to maybe install a storage area with pre-processing equipment inside your plant, with an unloading system, with a screening system, with shredding system, and so on. So there are very, very different points where you have to look for, just depending to the system and to the waste you want to use. So on the next screen you just see for the alternative fuel utilization from the KHD company, the overview of the points where you can use alternative fuels. So we are able to burn even alternative fuels in the rotary kiln by feeding it to the pyrojet burner or maybe satellite burner installed next to this kiln main burner. But you can see already in the sketch, we are really limited in the size of materials. We are here in the range of, let's say, 2 to 10 millimeters, depending on if it's 3D or 2D material. And this is really limited because this material has to be pneumatically conveyed to the burner. Otherwise, you cannot feed it to the main burner itself. So then the next step could be to have it directly feed it to a normal calciner, to the riser duct. There you see you have already an increased size of the materials. This means 5 millimeters, 10 millimeters, maybe 30 could be sufficient to burn alternative fuels. This is depending to the retention time inside the system and to the type of alternative fuel what you want to use. Then we have two other systems. We have the pyro incinerator, which is like a small burning chamber for low stoichiometric substitution rates, and also the combustion chamber. These two systems are already giving the possibility to burn alternative fuels in a higher size range. So we are talking here about sizes of 20 to, let's say, 50, 70 millimeters, just depending to the alternative fuels what you want to use. And finally, we have the newest development. This is our pyro-rotor system, where we are nearly unlimited to feed alternative fuels in very different sizes. You see, there's no problem to have material with 100 or even 300 millimeters of size. This is just depending to the conveying system mainly and the feeding system, what you're using to feed the material to this pyro-rotor, and even complete tires. Car tires, even truck tires, but truck tires, I have to say, this have to be cut in smaller pieces, not really small pieces, but smaller pieces, but complete car tires can be already also fit to this pyro-rotor. So now you see there's a rough overview of this usage, and at the end it's just a question by having the pre-processing demand and the usable particle size, which equipment should be used. So this means if you're getting already a high pre-processed material from your suppliers, you can use a more simple system or another system, easier handling system. But you have to spend a lot of money just for the pre-preparation process to get it into the right size and to the right amount, because also the amount is a very critical point by using alternative fuels. And there's also the possibility to have it in a low pre-processed size, and then by using, for example, the pyro-rotor. So now I just want to give you just a short introduction about the pyro-rotor. What is the pyro-rotor, how does it look like, and how it can be used. So the pyro-rotor is at the end a combustion reactor, which is using the tertiary air for burning the alternative fuel materials. It is directly connected to the calciner riser duct. You can see it here just in this overview, so installed above the kiln itself. And it's suitable for the usage of fuels with poorest burning properties. So we are talking there of calorific values of minimum, let's say, 3,000 kilocalories, so really on the low side. What we can burn there, you can use very coarse material with really low pre-processed pre-processed size, and as I already said, also by feeding whole tires. What is really important is that the fuel or what you want to feed there is available for the whole time for 24 hours. So you have to have the constant fuel amount of 24 hours per day, 7 days a week. So the system is reacting very, very clear to this amount of fuel what you're feeding. And with the pyrorotor, you also have the flexibility because you have sometimes the fluctuations in the calorific values coming from moisture, that the system is running very good with such a pyrorotor system. Also, you can reduce the fuel cost because alternative fuels is another point from the cost side. They are really cheap to get on the market compared to standard fuels. And you are increasing just the thermal substitution rate by using such alternative fuel powering system. So here just an overview how such a pyrorotor is looking like. From my point, I would say it's looking like a ball mill connected to the calciner. At the end, it's like a small kiln, like a small rotary kiln. So you see here the drum of the pyrorotor itself, the tires, where it's more looking like a small kiln. You see the connection to the calciner itself, and also here the connection of the tertiary air, what is used as burning air for the pyrorotor, the feeding chute for the alternative fuels, and also if you want to use complete tires, the separate tire chute for giving the tires inside of this pyrorotor. So although this product is really or pretty new on the market, now since 6-7 years we are using here in many points, very proven design. So the inlet outlet sealing, the bearings, the rollers, the tires, this is similar to our equipment which we are using since more than 40-50 years also in our rotary kilns. So you can see it here. Inlet chamber is looking similar to the kiln inlet chamber. The sealing systems are completely the same like we are using for the kiln inlet or kiln outlet sealings, and also the support rollers of the tires are pretty similar. Now also some photos from installations. These were from a European country, the installation. You see the base frame of the pyrorotor here where it is later placed on, with the rollers. They are directly driven with a motor, so we don't have the girth gear and pinion system like on the rotary kiln. We have directly driven rollers on the pyrorotor. You can see it also here, the rollers, or then later on the placed pyrorotor itself on this base frame. So how's the operating principle? How is such a pyrorotor directly working? So here you see the sketch. As I already given you the first impression, it's directly connected to an existing calciner system just above the rotary kiln, some meters above. You need an extraction from the existing tertiary air duct. This means you are taking out from the existing tertiary air a certain amount, approximately 50-60% of this amount is going as combustion air to the pyrorotor. And then you are directly feeding this alternative fuels inside this system and are burning the material here inside the pyrorotor. Because of the high amount of fuel and pretty low amount of combustion air, we are creating here a CO-rich environment inside of the pyrorotor, and the gases then are passing through the pyrorotor to the calciner, are mixing with the air which is already coming from the rotary kiln. And here in the remaining calciner, we are having the effect that the CO-rich gases are giving the heat in one point to the meal feeded from the existing cyclones, to have the heat transfer and all this to use the heat for the process, and on the other side also the CO rich amount which is reacting then with a NOx rich environment coming from the rotary kiln. So this means at the end you have a good combination of burning the alternative fuels, having the heat transfer to the system, and reducing also the NOx emissions in a certain level of the existing system. So the gas, what you are getting from the tertiary air, is leading up to a reaction temperature or burning temperature of up to 1200 degrees Celsius, which is giving you the good opportunity for a good burning process, for a good burnout of the materials, and the good behavior of these materials inside the pyrorotor. With a frequency converter, it's possible to adjust, just depending to the type of fuel which you are using, the retention time inside the pyrorotor. With the new sizes, we can increase this time of retention inside the system of up to 12 minutes now. In the past, with a smaller size, it was possible just to go up to 10 minutes. Now with the largest one, it's already increased a little bit. So this means with 10 or even 12 minutes, you are able to burn even very, very coarse material, huge lumpy sized material, even whole tires, nearly completely inside the system, inside the pyrorotor. And this is, I think, a really, really good advantage, because you're saving costs on the one hand for the pre-preparation, and have here in this system the opportunity to realize such a good burnout effect inside the system. And also, as already given on the paper before, the NOx optimized operation is possible due to the CO rich or lean gas reaction and burning processes. And yeah, just coming now to the sizes, what we have put it for the pyrorotor, and also some references. So the standard size is what we are normally using on the market. In this area, this means standardly we are offering pyroretors in the diameter of 3.4 or 4.2 meters. This is getting for the range of production capacity for clinker lines between 3,000 tons. There we are on the lowest side, and on the highest side with the 4.2 meters, we can suffer there, or we can offer there for plants with a capacity of 7,000 or nearly 8,000 tons. So when we are then in the range below this 3,000 tons, we have now also developed the smaller size with only 2.8 meters in diameter, and for kiln plant capacities over 8,000 tons, we have this 5-meter pyrorotor, and you see the amount of alternative fuels which can be fed to such a system. This means in the standard range we are talking here about capacity of alternative fuel feeding of nearly 500 tons per day, or even going up to 800, 900 tons per day. And this amount of fuel has to be handled also in your plant. You have to think for the size of the storage, for the pre-preparation. Okay, this is not necessary in this case by having such implementation of the pyrorotor. But you see there's a huge possibility, and you don't have a huge influence to the system at the end. So here on this sketch, you can also see that the demand of energy for the driving motors is also on the low side. So we are just talking about motor drives of 20 or 45 kilowatts. What is not that much. And finally, I just want to give you also some references where we have put all the pyrorotors worldwide up to now. 14 pyrorotors are already running worldwide. The main market is South Korea. There's installed several plants in South Korea. The demand is really high in this country. You see the standard sizes are here mainly used. You see also what we have made as additionally works. So in many plants we have changed in the calciner the pyro top. This means we have added an additional mixing chamber on the top of the calciner just to have a good mixing effect inside the calciner for the final reaction and for the combustion of these gases which we are creating in the burning process. You see which kind of fuels were used also in all these references. And finally you see also the substitution rates which we have given as guarantees and which were reached definitely or even more was reached during the commissioning phases. Unfortunately, up to now we don't have any reference here in the Vietnamese market, but maybe in the future it will come. The advantage is that for such a pyrorotor system you can easily install it into an existing plant without a low range of additional modifications which are needed. When you are looking to other systems like a combustion chamber or like other systems from other suppliers, normally you have to use also feeding of raw meal inside these systems. This is not necessary for the pyrorotor because you're just burning directly the fuel inside the system, and this pyrorotor is then just giving the heat and the hot air or hot gases to the calciner where your standard reaction and heat transfer between the materials happens. Yeah. At the end, this was my presentation. Just a rough summary again to see what are the key benefits and the key features for this pyrorotor. So you have a high flexibility with nearly all kind of unprepared alternative fuels. You can definitely reduce your fuel costs by using alternative fuels instead of standard solid fuels or other standard fuels. And it's a really future-proof system for changing the fuel scenarios in cement plants. It's retrofittable to nearly any kind of plant. We have implemented now, as I already said, with references in 14 plants. Now 2 other plants are near to the commissioning phase. One is in Turkey, one is in Portugal also. Which will be commissioned in the second half of this year. And there are also now already 3 more plants in the negotiations, also in South Korea, where the system will be added. So you see, there's already a high demand on the market, and maybe such a pyrorotor system is also a possibility for the Vietnam market. So at the end, I just want to say thank you that you've given me the opportunity to have the presentation here. If you're interested, we have our booth outside, so just come to our booth and then we can discuss the issues. Thank you.
Thanks, Andreas. Yes, as Andreas said, they have a stand out in the exhibition area, so do take time to visit him if you have any questions. His neighbour outside is Dirk from Kima Process. Dirk's going to be talking now about autonomous kiln and mill operations to dramatically reduce operational costs. It's going to touch on some of those key topics that we've already mentioned, including, I think, Industry 4.0. So, Dirk, please.
Thank you very much. Ladies and gentlemen, if this presentation was too technical for you, I have a higher challenge for you. So let me try to bring technical aspects not only from the common hardware in a cement plant, from the combustion, Now, to that, what is in everybody's mind when we speak today about the future of computers, the future of controls, when we speak about artificial intelligence. And I will not speak about ChatGPT, which gives you a nice letter, introduction letter, or something like that. I speak about something which is for you as cement producer, what we call the low-hanging fruits. Energy efficiency and also production improvement with an investment which is not huge. You operate cement plants with usually maintenance costs which are unbelievable because productions in the industry, like the cement industry, have the highest demand on wear and exchange of wear parts, what you can think. So with a very low investment, we can improve the energy efficiency and reduce, in the same time, the carbon footprint. KHD Process Control is providing solutions for automation and process optimization since 1996 to the cement world. You see here a very old dinosaur, a kiln with satellite coolers. Of course, you can change this and change to a grid cooler, but with much less investments, you can increase the production of a kiln line or a mill by 5 to 10%. And this is what I would like to show you in my presentation. KHD Process Control is providing this product, and we are not only providing automation in form of software, driving your mill and kiln line autonomous, like a Tesla car going from here to there without any touch anymore. This is possible with your cement plant also. But we provide also instrumentations which are designed specifically only on the cement industry. SmartFill is one of these examples which I will implement later in my presentation, where I speak about electronic ear listening in your ball mill to control the feed into this mill and to make a maximum production. Another product is the kiln cooler. And you see this kiln is painted white. It's not painted, it's the limestone which is in the water, which we spray onto a kiln instead of air cooling. Water onto kiln. A lot of people are scared to think about only that. Forget that. We don't take a big water hose or garden hose and put water. We make a water mist on this kiln. And the limestone which is in this water remains on the kiln, so we paint kilns white. The target behind is energy reduction. What you do today by cooling with air blowers, we cool in the meantime with a water mist, more efficient, less cost intensive. We designed another instrument which I would like to introduce in my short presentation, the gas temp flow system, which is a specific measurement system on acoustic measurement principle, which measures gas flow and gas temperature rapidly, fast, and more precise than ever each instrument before, which opens us an opportunity to operate and control your kiln much, much more precise. Control the kiln, controlling mills. We have a software called Smart Control, and this is based on artificial intelligence. Modules of high-level control systems, where I show you in my presentation what is the result, what we can reach. Now, if somebody speaks about artificial intelligence, there is a wide range of fields what artificial intelligence covers. It is not only ChatGPT. If you see the left side, the red one, general AI, I can tell you that finances, insurance companies, banks, stock exchange work with this artificial intelligence to predict what is happening with my money, with my investment, about the markets, and so on. This is artificial intelligence. Artificial intelligence, in most people's mind, is that a machine, a computer, can learn something. Yes, possible. This is machine learning. KHD is using this technology, as I show you later on, for mills and kiln operations. But the main product which we supply since more than 25 years is that we take the operators' knowledge from your operators in your cement plants and convert that bilingual-based programming into the control of mills and kilns. And this is knowledge-based automation. Knowledge-based automation is fuzzy logic, and fuzzy logic is not old-fashioned in this kind of industry. The cement industry with a cement plant has the highest challenge to be controlled by AI. Why? Because of this wear. You have huge wear in your grinding stations, from the raw mill, in the cement mill, and you have huge variations also from the input materials. Yes, the limestone. Just have a look onto your quarry. You see a couple of colors. Only these colors describe already the unhomogeneous raw material, which has to be made homogeneous to make a homogeneous cement afterwards. The other aspect, alternative fuel. And when we heard earlier about the pyrorotor, of course you can put a lot of things inside, but these things which you put into the pyrorotor has always changing heat variables. And these heat variables has to be covered, has to be compensated. AI can do that, and we do that since more than 25 years, as I said. Look onto the energy demand of a cement production. And here it becomes very interesting. The electrical energy consumption to produce 1 ton of cement. Here you see the big portion in blue and the big portion in orange. So 2 of 3 energy demand portions comes from grinding. So the ball mills and the vertical roller mills need so much electrical energy that we as KHD provide you a system which can easily, with 1 week of commissioning, reduce these costs by 10%. Low-hanging fruits. And this is what I would like to show you, that with specific energy, specific instrumentation and control software, we are able to cut 8% of the entire energy production which you need to produce your cement. And what makes that possible? The difficulty in cement grinding is the changing grindability of the material, the hardness. And here it is necessary to measure this hardness because this drives the time, how long it has to be in the mill. Using electronic ears since years is the answer. And KHD Process Control provides a market-leading product here, the electronic ear Smart Fill, which is installed of over 900 ball mills all over the globe. And all big players in the market are using these electronic ears, not only in combination with our optimization software, also with their own expert system. So if you compare it to older technologies like this microphone system, you will quickly learn that a microphone system, you can buy that for $5,000, listens into your mill, yeah, but it listens also to the other mills because there is crosstalk between the mills, and you have an ear which is open for everything. The KHD product is completely different. We are installed on the mill body itself, and we listen, as you can see in this small video here, with a box on this mill, precisely in chamber 1 and chamber 2 with vibration sensors. And these vibration sensors, which you see here, are covering structure-borne sound. So there is no chance from outside noise, acoustic noise, to be implemented in this measurement. So we are usually 10 to 20 times more precise in this necessity to measure the fill level. And the fill level is measured here also on a 360 degrees analysis. So whenever you have wear in your balls, try to imagine that, the flying curve will change. So microphone systems has to be recalibrated usually once per month, once per 3 months. No necessity with this system because it's always getting the main impact point at any pace. I jump a little bit about that because we don't measure only here the precise fill level in chamber 1 and chamber 2, but also the temperature in the diaphragm. And this avoids dehydration of the gypsum in cement mills. I don't want to be too technical because you are more concentrated on the cost efficiency of production. So let me tell you only that with this instrument, you get the opportunity to find a so-called fingerprint for the optimum adjustment of the mill for each type of cement. So when you change in your production, in your one ball mill from ordinary Portland cement to a fine cement, a slag cement or a limestone cement, this system knows in advance what is the optimum adjustment, and you don't have to wait for the laboratory values, which come usually 1 or 1.5 hours later. Saving time, avoiding the so-called intermediate product, so a product which you usually mix under your quality cements, and an always optimum in the process is the result. And you see that short on this slide. On the left-hand side, you see the green and the blue graph showing the fill level in the mill. And very short, you can imagine in this moment, when the mill is full, you create a complete different cement type as here when the mill is empty and grinded completely out. On the right-hand side, you see the graphs then when the mill pilot or mill master is operating the kiln, our control software, high-level control software, instead of the operator. Now, let us come to that what is more interesting for you. I don't go here on too much on the technical aspect. We speak about AI and AI driving your mill. This is what you see here in this graph. Operator. The operator, you see the yellow graph, and the red dots show the interaction. This is a laboratory value the operator gets each hour, and based on this laboratory, he starts an interaction. He changed something on the mill. And you see it's always too late. You're always running behind. So blue is what the mill master does. He knows in advance because he can predict early what is happening. So he is much sharper and immediately controlling in this moment the interaction and take over from the operator. The operator steps back and let the computer do it. Good decision. Now, with this control, we even get a better quality of the product. This is what I wanted to say, because it is more and more important today that you have your cement quality sharp there where it should be. And this system allows to reduce the left and right. It makes more sharp that what you would like to do. And now come to figures. I said at the beginning, we can reduce energy content nearly by 5, 8, 10%. I give you an example. You have a production of 130 tons per hour. A ball mill, 130 tons per hour. Now, you operate at usually 7,200 operational hours per year. Your relative power consumption is today, without smart fill and mill master, 65 kilowatt hours per ton. When we say now we expect minimum 5%, and ladies and gentlemen, 5% we reach always. I show you case studies later with 10 and 12% production increase or energy consumption reduction. Now, reduced electric power, absolute, 3 million kilowatt hours. So 3 million kilowatt hours with a cost of 10 US dollar cent per kilowatt hour, a normal price for power, saves you per year 304,000 US dollars. So return of invest of such a system is less than 5 months. I show you now case studies, and the case studies show that Eastern Province Cement has has increased the production by autonomous mill control with 9.8% on the first mill. The second mill we have done with Eastern Province Cement in Dammam, Kingdom of Saudi Arabia, was 9%. We have Al Safwa Cement, similar. The improvements are here between 3.5 and 4.5%, and you see the specific power consumption even drop in the same manner. We see YTL Kantan plant, which is in Malaysia, where we have reached on cement mill 5 and 6 with autonomous operation a production increase of phenomenal 6%. And this 6% is not only to see in the graphs, it is also to see in the performance letter which we get at the end from the customer. Certified, stamped, signed. So Saurashtra Cement, Meta Group, okay, there we catch the bird, let me say. From manual operation of this mill to autonomous operation, we have reached incredible 12% production increase. And you see that easily also on the graphs. You see here the fresh feed controlled by manual operation and the big losses which are always there when manual operation is taking place. Below the graph with mill master and the production increase. Now this technology of AI control is not only to use on mills. You have seen the example of ball mills. The same software can be used for vertical roller mills, for roller presses, and for the combination of both. I visited 1 year back Visai Cement here in Vietnam, and I have shown there also that in the combination of roller press and ball mill, there's a huge optimization potential, and I think we will come close to negotiate here a first pilot project in Vietnam as well. However, we have another solution with AI for the kiln. And here we have to talk about not only, again, the software, we have also to speak about a necessity of having better instrumentation. Today, kiln lines are operated in 3 control loops. The kiln line is separated in the preheater tower with calcination, the kiln line with main burner, and the clinker cooler. Everything is controlled by itself. But there's a huge interaction, as you can imagine. There is a gas flow between these modules and, excuse me the word, but we are technicians, enthalpy. Enthalpy is energy. So this energy exchange between these modules is necessary to measure. It was not possible before, but KEMA designed a sensor called gas temp flow, which measures precisely temperature and airflow. So now it's possible to bring all these 3 modules which were separated, controlled before, into one optimization package. We control the entire kiln line, and we install, you see the yellow spots here, the gas temp systems, which measure now precisely the exchange between preheater, kiln, and clinker cooler. With this optimization potential, we can reach that the exchange between these modules, which creates a so-called shifting. There is usually a shifting between these modules. We can reduce this shifting and keep the energy always on the same level. And now I give you a figure. Using this control philosophy and this precise measurement in between, we are able to reduce the energy consumption of a kiln between 5 and 10%. Have you an idea how much 5 to 10% energy costs of a kiln line mean? We speak about millions of euros. So what you see here is a first ever have done balance sheet of the mass flow and the gas flows, again, the enthalpy exchanged between these modules. And here we have the opportunity with a time scale to move in the time and look also when something happens. What was the reason? And I give you some example. This example could be, for instance, the fuels in the pre-calciner. The fuel change from a KHD pyrorotor. The pyrorotor is working proper, but instead of tires, there are no more wood chips inside. In this moment, the heat value change. With this system, we immediately see the effect on the entire pyro line what is happening and what to do. The system is covering that. Or the main burner, if the main burner flame changes the energy content, we know immediately what to do, so we can reduce the energy costs. The key of this success is the gas temp flow measurement system, which is certified already. CRH plants, Lafarge plants, Cecil plants, Butzi, Unichem, Dükerhoff, Heidelberg Materials, and Schwenk. And it is a very fantastic tool for each process engineer and for each production manager, because it helps much, much more to understand what is happening in my process today. It can measure gas temperatures and flows on the downcomer, on the calciner exit, the tertiary air, the flue gas stack, bypass, and the secondary air, as well as vertical roller mills. But now, again, figures. To come to a cost reduction using this gas flow measurement, I would like to show you an example from the downcomer. The downcomer installation, very easy. You see just these 3 sensors. You see that we installed it in the Heidelberg material plants on both strings of the downcomer. And the investment cost of, attention, 30 to 35,000 euros per one system can be converted in a return of invest computation very easily. We measure with a precision of plus minus 1% now the airflow. Today, with existing temperature and flow gas measurements, you are using Venturi or delta P measurements. These measurements have an accuracy of plus minus 10%. Now, to operate on the safe side, you produce in your ID fan, you suck now, instead of 500,000 norm cubic meters, 10% failure, 550,000. With a precision of 1%, which we get from the measurement, you can reduce 9%, at least 8% of gas in this moment. And this is what I show here. Your ID fan power consumption per hour in a 4000 TPD line is usually 2 megawatt. So we speak about 2000 kilowatt hours, which you use just for the ID fan. So if we reduce that by 8%, which is possible with gas temp flow, you have a reduced electricity consumption of 1.2 million kilowatt hours. Again, 10 US dollar cent. The savings per year are $128,000 with an investment of 35,000. Some people say we are too cheap. No, this is the valuable price. But it should be thinking to invest in such a very cheap thing, low-hanging fruits, you remember, to make your plant more energy efficient. I think we are the right partner for such better energy efficiencies. I have my booth in the exhibition hall, and we have not only these products, specifically instrumentation and control software. We have a 25 years knowledge about optimizing cement plants, grinding sections and pyro sections. And I would be pleased that we come into a dialogue. I myself, Dirk Schmidt, I'm sitting here in Hanoi. I have my Asia Pacific office in Hanoi established, so very near to the Vietnamese cement industry, but of course also to Thailand, to Malaysia, to Indonesia, Singapore, whatever, India, Australia. Let me say Australia, we have a market share in the meantime of high-level control systems for mills in Australia of 85%. So there are just a few plants anymore which not operate their mills without our systems. And one I can tell you and promise you, these technologies are not anymore a nice to have. To be competitive in cement production, there is a serious need to have them in future. That was my presentation. I hope it was interesting, and I would be pleased to come into a personal dialogue later on the booth. Thank you so much.
Thank you very much, Dirk. Yes, as Dirk mentioned, there is a stand outside where you can go and put your questions to him. We're going to break now for coffee for 45 minutes, and we'll start again at 11:45.